Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
In last lecture, we discussed about single phase induction motor, and we also saw that there are three types of single phase induction motor. The first one was split phase induction motor, then second was capacitor type induction motor, and third was shaded pole induction motor. Now we also saw that this categorization was done on the basis of the starting method, because this point is very important, that single phase induction motor are not self starting motors as it was a case in three phase induction motor, right? So in the last lecture we discussed about split phase induction motor. So in today's lecture we'll be talking about the remaining two. So we shall go ahead now. So second type comes capacitor start induction motor, and now here you have two ways of connecting the induction motor with a capacitor. Now let me tell you that this type of motor has very high starting torque, because in the last lecture itself we discussed that the torque was proportional to sine alpha. It means that I could say that this torque, starting torque, is also proportional to alpha. And our main concentration was on how to increase this alpha. What was alpha? Alpha was the angle between the starting winding current and main winding current, right? So suppose this is main winding current and this is starting winding current, which is also known as auxiliary winding. Okay, so this angle was alpha. Fine. So that starting torque was proportional to this sine alpha. In turn, I could say that torque was proportional to the value alpha. Don't get confused between the proportionality sign and alpha. Fine. So the advantage of these motors, I said that these motors have very high starting torque, right? It means that the angle, that was the split angle between IS and IM, in this case is quite large. Now, how do we make it large? So what we have done is, we have connected a capacitor here. So what is the job of capacitor? Come on, what is the job of capacitor? Capacitor obviously increases the phase difference. Fine, okay. What is the property of capacitor? That the current in the capacitor leads the voltage by 90 degrees. Remember that concept? Yes. And generally what is done is, the capacitor is mounted on the top of the motor frame, and usually an electrolytic capacitor is used. And here also we have centrifugal switch, which is this, so that when motor reaches 75 to 80% of its maximum speed, automatically this centrifugal switch cuts off the starting winding. And once the rotor attains 75 to 80% speed, even if you remove this auxiliary winding or starting winding, it does not have any effect. It continues to rotate. Okay? Yes. So basically the addition of capacitor increases the phase split. Fine. Now this type of motor is very popular for heavy duty applications. Now what are heavy duty applications? Like compressors, jet pumps, okay, and some pool pumps. In swimming pool also pumps are used. Okay, so because swimming pool requires a lots of water, the swimming pool has to be filled up, and while vacating also the quantity of water is quite large. So these are called heavy duty applications. Okay, so let us see the phasor diagram. So this is the phasor diagram. Fine. Now you can study this phasor diagram. Now what does it tell you? What does it tell you? Now you can very well understand that here this is our auxiliary current and now this is the main winding current. So you can understand that this is auxiliary current and this is main winding. So just imagine the value of alpha, which is quite large. Now why we got such large value? Because of the addition of capacitor, and we know that capacitor naturally increases the phase shift, isn't it? And it leads the voltage, correct? So this, see, I shall draw it again. Yes, so this is the voltage. So ideally it is actually here, right? But practically if I see, then it will have a smaller phase lead. So if this is auxiliary winding current, fine, here is my main winding current. So this is the value of alpha. Now when I draw the parallel line to these two, this is the intersection point, okay, and this is my resultant current I. Now in case of capacitor start induction motor, the value of alpha can be as high as 80 degrees, which is very high value. The ideal value of alpha is 90 degree. Okay, so this value is quite high, and that is why we say that this type of starting method is quite popular. Okay, so I think you have understood the working. This is the speed torque characteristics. So we get a very high starting torque. The speed is also large. Now the advantages of this type capacitor start induction motor is it increases the overload capacity of the motor, and the power factor of such induction motor is very high, and as we have already discussed that efficiency is also quite high. Fine. Let us go to the next type. Now the next type is shaded pole motor. So you can see the arrangement. So what do we do here is, yes, so see here you have, actually this was the pole, normal pole, but in case of shaded pole, what we do is, instead of such type, we have a small stamping here, okay, a cut here, okay, and a copper ring is inserted here. Fine, okay, I hope you understood this. So see, this is the copper ring. Fine, that is called shading band. And we have the stator winding. It is same as like squirrel cage rotor, so you have a squirrel cage rotor inside it. This is drawn exclusively for our better understanding. Okay, so let me tell you that this part on which the shading band is given, okay, it means this particular part. This is called shaded portion. Okay, this is called shaded portion. And this part is called obviously unshaded portion. Okay, so Ideally, our pole was supposed to be like this, but then what do is we have here a small cut and we have a small copper ring or shading band. Fine. And after this, we have winding. Okay. We have winding here. And we give here supply. Got it? Now here some supply is given. So the current starts flowing. So this develops the magnetic field or flux. Now this magnetic field passes through all this area, isn't it? It passes through all the area and in turn it cuts this shaded portion. So due to Faraday's law of electromagnetic induction, eddy current is set up in this shading band. Or else, in other words, I can say that you have the windings here. Okay, you have the windings here and current is flowing, and in between you have this shading band or shading coil here, right? So this flux is cutting it, correct? It is passing through it. So a magnetic field is induced in this shading coil also. It is a single turn, copper band kind of thing. Okay, it does not have a multiple turns. But then magnetic field is induced. So flux is induced. Now since that flux is continuously changing, what happens? An EMF is induced. And that EMF, since it is a band, so it is a closed circuit, isn't it? It is a complete circuit. So the current starts flowing. And that is why just before 2 minutes, I said eddy current is produced. So basically this phenomenon occurs and in turn the produced current opposes the cause. Now what is the cause? Cause is the magnetic field which is produced by the unshaded portion. Right? So what happens in case of induction motor? What happens in case of induction motor? Yes. So this tries to catch up. This tries to oppose the cause. Correct? So in turn a rotating magnetic field is produced. Fine. And finally our rotor starts rotating. I hope this is very clear. Okay, I'll repeat. We have a shaded band or shading coil. Okay, now when we pass alternating current through the field winding or the stator winding, the magnetic field cuts the shading part. Okay, and again magnetic field is induced. Fine. So this induced magnetic field produces the current and this current opposes the cause. Okay. Yes, so this current opposes the cause. So magnetic field rotates from shaded portion to unshaded portion. Okay, shaded portion to unshaded portion. So it means now the magnetic field starts rotating. Okay, so since magnetic field starts rotating, obviously rotor starts rotating because it has to catch. Okay, it has to catch that rotating magnetic field. So rotor also starts rotating. Fine. And I have a correction here. The magnetic field rotates from unshaded part to shaded part. Okay, unshaded part to shaded part. So I hope this operation is clear to you. But then the problem is these motors cannot be of very high size. They are small motors, okay? But they are very commonly used. And let me tell you that basically in the, when these motors were invented, actually these motors were invented in the beginning. and the invention of this motor is as old as, say, some 120, more than 120 years. Somewhere around 1890 these motors were invented, and these are quite popular, but then the problem is they have very high losses, and because of high losses the power factor is less and efficiency also becomes less. So you cannot uh, build very big motors with shaded pole motor, okay, shaded pole technology, because otherwise the losses will be very high. So these motors are quite small in size, like you can say in smaller fans, say exhaust fan and hair dryer, and sometimes yes, I mentioned exhaust fan. So wherever the size of the fan is quite small, these types of motors are preferred. And I've already told you the advantages are, of course, you have you know very rugged induction motor, and they are quite cheap if you compare other motors. But then disadvantages are going to be low power factor, low starting torque, low overload capacity, lesser efficiency, and more losses. Okay, so this was about shaded pole induction motor. So here we complete single phase induction motor, and we shall be discussing stepper motor in the next lecture. See you until then. Take care. Goodbye.